This is video 10.1.1, and the goal here is to understand what it means to simplify expressions. And we're not just simplifying any expression, it's actually rational expressions, which means fractions. So we're going to be looking at rational expressions that look like the first example here. So our goal is to simplify this so it's not as complicated. Of course, that's the opposite of simple is complicated. And the first thing that we need to understand, and the first step to simplifying expressions is to factor the numerator and denominator completely. Okay, that word completely is a key word because the more completely you factor it, the better you'll be able to fully simplify it. Okay, if we only factor it part way, not completely, then we're not going to be able to simplify it fully, and we'll lose some points on a test or quiz when we're asked to simplify expressions. So factoring, that we can do. We're good at factoring. So we're going to think about the numerator and the denominator separately, and we're going to start with factoring the numerator into a product. So remember, that means a product. Usually we write that with parentheses to describe the multiplication. So when I look at 3y squared plus 15y, remember with factoring, you first want to look for a common factor. What do they both have in common? So when I look at these two these two expressions, I see they both have a y, and I see that 3 would also go into both of them. So when we factor completely, we have to start sometimes with a smaller rectangle and find that common factor like 3y. So I'm factoring out 3y, and remember my sum goes on the inside. And I think about 3y times what would give me 3y squared? Well, 3y times y. And then 3y times what would give me 15y? Well, 3y times 5. So far I've factored because I can rewrite this problem as 3y times y plus 5. Think of this as the opposite of the distributive property. We're going backwards. We're undistributing 3y. Now what we do though is we do want to look and see, can this be factored further? And in our case, no. Y plus 5, that's very simple. It cannot be factored any further. If there was a y squared in there, we'd have to keep thinking about what to factor out further. So the top can be factored into 3y times y plus 5. Okay, so we start by factoring it that much. Now, we move on to factoring the denominator. So the denominator, the bottom of the fraction, 10y plus 2y squared. Once again, I want to look for a common factor that both of these numbers can contain. So it looks like they both, once again, have a y. So I'm going to take out a y. But I also see the 10 and the 2 both can be factored out of 2. So think of it as dividing. We could divide both of those by 2. We could also divide both of those by y. And it would still give me a nice whole number. So that means that inside my rectangle, since there was a common factor, my problem starts like this. I'm going to use a smaller rectangle and just factor out 2y. 2y times 5 equals 10y, and 2y times y equals 2y squared. So this can be factored into 2y times 5 plus y. Okay, so I have the denominator factored into 2y times 5 plus y. So I did step 1, factor the numerator and the denominator completely. Step 2, simplify the fraction. And remember, when simplifying, your goal is to find all values that are equal to 1. You're finding those big ones, because anything divided by itself equals 1. So when I see here, I see a big 1 right here. The y over y makes a 1. And this, in fact, makes a 1. Because really, the bottom could be written as y plus 5. That's the same thing as 5 plus y. So when I have that on top and on bottom, that is a 1. So let's think about this again. The reason we can find these ones is because this is a product on top. This says 3 times y plus 5. The bottom says 2 times y times 5 plus y. So these are 3 factors on the bottom and on the top, which is why when I find these ones, I can just cancel them out. They're gone, because anything times 1 is itself. So this problem simplifies all the way down to 3 over 2. That is the simplified answer, 3 over 2. Yes, you could write that as 1.5, but you can leave it in fraction form as well. The fraction form is just fine for your teachers. So there's your answer. 2 steps: factor, then simplify by getting rid of every large one. So let's take a look at example 2. In example 2, we're going to start with step 1, factoring. Then we're going to do step 2, simplifying. So step 1, factoring. So I start with the top, and I want to factor that. And this looks like just a typical polynomial with x squared. And I'm also going to factor the bottom. So let's see the top. So I look for a common factor, but there's nothing all 3 of these terms have in common. So just like we talked about in the last step, I actually don't have to do that this time because there's nothing in common. But I do need to use my generic rectangle and my diamond problem. So x squared, negative 6. And the diamond problem is negative 6x squared and negative x. So now I have to think about what multiplies to negative 6 but adds to negative 1. And that would be negative 3x and negative or positive 2x. Because that would make a negative 6x squared and a negative 1x. So that goes in my diamond problem. And then I fill in the outside. Let's see, this will have to be 2 and negative 3. Hopefully many of you are becoming really fast at your factors. So the factors are x plus 2 and x minus 3. And I have my factored numerator. So my numerator has been factored. Now my denominator. Let's factor the denominator. Okay, so you have 2 sets of factoring in almost all of these problems. So the denominator, x squared minus 8x. X squared minus 8x. I'm going to write it underneath this. I want to write it as a factored problem, so I can put it and make it look like this as another set of parentheses at the bottom. So let's see, generic rectangle and my diamond problem. X squared, 15, and negative 8x. So we need to multiply the 15x squared and add to negative 8. So that means both the answers are negative because it multiplies to positive but adds to negative. And it must be negative 5 and negative 3. Because that multiplies to positive and adds to negative. So I'm going to put that in my generic rectangle. And then I'm going to fill in the outside. And now I'm going to add that to back to my fraction. It's the bottom. Now I have the top and the bottom both written as a factored polynomial. They're written in a product form. So remember, these parentheses mean multiply. And so if I can find the same thing on top and bottom, that would make a 1. These are the same thing on top and bottom. That makes a big old 1. So I can cancel that because I don't really need to multiply by 1. It doesn't change my answer. And my simplified product is, simplified expression is x plus 2 over x minus 5. That's my answer. You don't have to put the parentheses in your final answer, but it doesn't matter. There's your answer. That's as simple as it gets. Remember, you cannot, this is not right, you may not cancel the x's here. That is not legal. That is not a 1. Because the top is written as a sum. It has this plus sign right here and this minus sign here. It's not a product. And the only time we can make a 1 like we did here is when we have a product. And we had this thing times this thing. And that means it's a product on the top and on the bottom. So I cannot cancel any further in this problem that you saw here because it does not have a product on top and bottom. It has a sum, x plus 2, and a difference, x minus 5, in the numerator and denominator. So do your best on your next set of problems. The questions you're going to encounter next are going to continue this process. Remember your simple 2 steps. You want to factor, then find your ones that can cancel. Okay, so 1 is your friend here when you're simplifying fractions like this. So be sure to ask your teacher questions and check back. And be sure to ask your teacher questions if you're not sure how to do this, or check your answers with